So, moving further away from philosophy towards the practicality, I just thought I'd quickly give you a snapshot, for those who don't read European history, of where we are in UK infrastructure. Most of what we had developed, we developed in the early part, mid part of the 19th century, 200 years ago. So at that time we were a world leader in water, waste, urban, long distance road and rail, and we still have the benefits from some of that. Then much later on, in the 1950s and 70s, we expanded national motorways, we put in nuclear power, we exploited North Sea oil and gas. In the 80s and 90s, for political reasons, we started leading the world in some ways in privatizing the ownership and operation and investment in all of those components. Telecommunications, water, energy, rail, so that the decisions about investment in infrastructure were much more likely to be driven by markets than by political or national imperatives. This is an observation, it's not a political judgment. And we pioneered, in some ways, new forms of private sector engagement, PPPs and PFIs. Now all of that infrastructure is between 250 years old. And what we have is challenging targets, particularly with regard to energy generation in what we regard as a low carbon world, but also replacement and renewal of a lot of aging infrastructure in the context of market forces which tend not to look for returns on investment over those long timescales and don't have a well-developed perception of the public good in the market model. So we have gone down a trajectory which leads us to a place where we make things extremely efficient from a market point of view, but not necessarily from a societal point of view. And what we're about is trying to move ourselves into a better position with regard to that. So again, just to give you some framework, what our numbers look like, we're obviously a much smaller, much denser country than you are, between about 58 million people in the UK. We've got these numbers. Railways have suddenly become very attractive for people to travel on because our roads have got really quite congested. 24,000 trains per weekday throughout the land, a lot of them in and around London. We have a very well developed high voltage grid, and then a very even better developed regional electricity distribution network, most of which was put in prior to privatisation. And it is actually very resilient because of that. But what's interesting is as they now are looking at modernising it and taking it forward to deal with new threats that we now understand, understanding how to do that with the architecture that they did have when it was in the public domain is much more difficult to justify in a free market domain. We also have, for 60 million people, 18 million broadband, residential broadband connections added in excess of 2 megabits. There's, as you mentioned, a major push to expand that, and I'll mention broadband a bit more later on. But the London sewerage system, to pick on one more local, was put in the 19th century by a Belgian architect and engineer, one Mr. Basil Jett. He put that in with 3 times the capacity that London, in terms of population, was likely to have, which is why it's still working, because we're now about 3 times the population that London had then. It was about 2 million then, it's pushing 6 to 7 now, which is worrying, because that means the sewerage system is pretty well at capacity. And as you can imagine, those of you who've been to London, the thought of replacing the sewerage system is just an absolute nightmare of a programme to think of doing in the context of the density, the efficiency that London runs itself at, and the public health issues that come from changing that particular part of our infrastructure. So those are just some of the numbers. Sorry, one more number. Bridges. We have a large number, in excess of 40,000 railway bridges, either carrying railway or roads in some intersecting way. And a lot of them have not been changed since we built the railway 150 years ago. So even just understanding the assets we've got and the nature of them, they're not smart at all. Most of them are really dumb. And they're built out of engineering materials that are that old. So that in itself is another challenge. So that's where we've got to, and these are therefore some of the concerns. It's an unregulated growth in the interdependency between all these components. We have interactions between water, waste, IT and energy and transport in a way which we really don't understand because no regulator looked at the interdependency between them. They were individually to a greater or lesser extent regulated, but not the interdependency between them. The population growth and radical change in living and working practices in the last 50 years in particular, but largely driven by the motor car, has caused our infrastructure to be now misshapen with regard to the way in which people want to live. Most of it's privatised. In fact, a lot of it is internationalised. A lot of the companies that own the operation of our infrastructure, although they may be running through limited companies inside the UK, are actually owned by foreign companies. And that, of course, has all sorts of implications for how we manage it from a central government and local government point of view. And as has been said before, we are in the position where there's no central government of infrastructure as a system or as a system of systems. So this is where the analysis had got me about about 2 years ago, and I'll tell you a bit more about the history in a moment. Oh, I'm sorry, there was one other thing. Little, which of course you can't read. That says little investment in resilience. There you go. Something to do with IT and displays here that we need to think about. So we haven't had investment in resilience because the market doesn't need it. The market will insure against damage, which is fine for the replacement. You can use money to replace certain elements of infrastructure if it gets damaged. But it doesn't replace the social or equitable value, and it doesn't replace the impact on lives of major problems. So that is another cause of concern. I'm now very rapidly going to canter through some sort of pictorial examples to give you a feel of what it really looks like. So this is a relatively new gas-fired power station that is being built. Nuclear power stations, which we have by the sea. We don't have earthquakes, thank heavens. We're populating a lot of our coastal regions with wind farms, both near, in and deep, and we have major targets to achieve. A lot of new work and new energy, economic energy is going into this particular area to give ourselves some renewable energy and sustainable energy capability. And this is a energy from waste plant where we're using domestic and industrial waste and turning it into heat for power generation and district heating. This is a quick map of the grid which shows you how sophisticated that looks like, and it's actually physically manifested, not unlike yours, with features like this around our landscape, which sometimes we find because of housing areas and settlements that have been put on floodplains, you end up with, particularly the picture of the local substation being in a floodplain as well. And those of you who follow flooding, and I know a lot of you will, we had a major flood in 2007 where we had the option of letting either substations which denied electricity to 10 or 20,000 houses go under, or another one which would have taken the water supply under for 300,000. It was a no-brainer. We actually had to switch the electricity off because we couldn't let 300,000 people have no water. But in response, those are some of the issues you need to understand. And this community actually is quite sophisticated. It does understand the resilience and operational planning in some level of detail, but other parts of our infrastructure operations do not. And so responding to extreme events is sometimes quite difficult unless you've mapped it properly. Energy use per capita in the UK has stabilised, and we're moving very fast now into demand reduction for all sorts of reasons in order to get ourselves into a better position. What's interesting, of course, is the curve at the bottom, because that is now, and that's 2005. We all know those curves are screaming up at a rate which is just going to distort the figures. But energy consumption per capita is something we have a major political agenda to try and reduce. This one might interest you. This does say 1790 on the left-hand side. And what we plotted with the Institute of Civil Engineers, that's what ICE stands for, is the number of kilometres of transports of different modes going right back to when we had turnpikes. These were unmetalled roads that horse-drawn carriages went along in the 18th century. They were rapidly followed by canals for carrying freight, largely. We used to carry our freight around the country in canals in the 18th century. That was overtaken by the railways, the yellow line, as you can see, followed by trunk roads, which were almost the same as the turnpikes, except we put proper tops on them, and then, by then the internal combustion had been developed. And then we replaced them with motorways. Now, were you an investor over a period of 200 years and said, what do I invest in next? And how long does it take before I get the return on my investment? It's curves like this that show you some quite interesting paradigms. I've yet to get enough data to put broadband on this, because that's the next paradigm. Of course, it don't travel, but project yourself virtually. But my guess is it's going to look exactly the same. And then the question is what comes after that. Because this is the sort of thing that would be the same in most countries, depending on where they started investing in large-scale infrastructure. A map of Roman roads. Most of our big trunk roads and some of our motorways are in identical places to where they were put by the Romans 2,000 years ago. The topology of a country tells you the right way to do it, and quite often you get it right first time. But then if you want to change it to some extra level of capacity, you're stuck with the fact you're using this thing for whack right now, and you've got to add to it whilst not disturbing the current situation. We're having that problem with our railway systems, and I know from talking to colleagues, you have that problem as well. The early settlers got it pretty well right the first time around because it was the easiest and cheapest solution. And we're finding that, except we have a little bit more throwback to a long history. This is a railway map of central London, 1880. This is a railway map of London now. I couldn't get two that actually mapped on top of each other, but when these are released, you can spend a sleepless night looking at the detail and see there's actually not much changed. Urban railways tend to be stay where they're put. And it's very difficult to change them. It's very difficult to add extra capacity. So there's something about thinking ahead when you put in new railway systems in urban areas, because they're very difficult to change afterwards. And we've discovered the legacy of that in London in particular. And this is what we euphemistically call the London Underground system. That's why I put the word system in italics, because it's not treated as a system at all. Yet you as a journey person inside the London Underground system would expect it to behave as a system. You'd expect there to be good communications between the various lines, not a bit of it. They're run as separate profit centres. So they won't tell you about what's going on another line necessarily. Actually, I parody, they're beginning to do that. There's now places where you get some information about what's going on. Only actually that it's no disruption or some disruption, or it's stopped for some technical reason or otherwise. But if you are changing lines, what would be really useful is, do I have to run to the next interchange in order to get the train I want to get? Because there's going to be one there inside 45 seconds. Or it's going to be 3 minutes and I can walk at a more leisurely pace. No, we don't have that information, even though each line has that information for itself. So the information exchange around the London Underground system is very, very coarse-grained and is actually aimed at the operator, not at the passenger. So that's why I tease the word system, because that is exactly what it is not from a passenger point of view. And as you can see, and for those of you who've been in London, it is actually a fantastically good system when it works, except it isn't a system, it's a set of interrelated lines. So the planning context we now live in is one where we have a lot of freight on our motorways, very congested. This is actually what happens when, dare I say, this is what happens when the French go on strike and close the tunnel, because a huge amount of our freight now comes through the tunnel under the English Channel. And so we park lorries on one of our motorways, which completely screws up all the other form of transport we can have on that motorway. We're suffering from major congestion on our motorways. We're suffering from huge port capacity inadequacy. I sort of heard that even in Australia, which surprised me a bit, but there you go. Dover is by far the busiest port, and the Channel crossing is one of the busiest seaways in the world, let alone in Europe. Airspace, which is the asset through which aviation works, of course, is also heavily congested over the southeast of England in particular. And we've just had a political decision made that we will not build another runway in the southeast of England because we want to rejuvenate growth elsewhere. The evidence for that being a really good idea is slim. And we have very old major intersections. The railway buffs in the road, this is Clapham Junction, which is sort of famous as one of the busiest junctions in the world, let alone in the UK. And the ability to change anything in this area, which takes about 10 trains a minute through it at peak times, everything would be paralysed if we try to do anything with it. And yet we know we've got to do something with it. And how you do engineering on brownfield sites of new solutions is quite tricky. So that's the planning context in pieces.